I will start with the ratio test. So use the ratio test. And I need to do the ratio of a sub n plus 1 over a sub n. We'll do the absolute value of that ratio. So it's going to be -1 to the n plus 1 x. Now this would be 2 open parentheses n plus 1 over 2 raised to the second power open parentheses. Every n becomes n plus 1, and if n is being multiplied by 2, well, n plus 1 is multiplied by 2. And there's my, I put my factorial in the wrong place. I think it's okay right there. I think I need it right there, as a matter of fact. I need n plus 1 in parentheses because it's n plus 1 factorial. So I put an extra set of parentheses in there for the square. So then times 2 to the 2n times n factorial squared, and then over -1 to the n times x to the 2n. Get the pieces that are alike together. So I'll have -1 to the n plus 1 over -1 to the n. And then I will get x. Let's distribute this 2. This would be x to the 2n plus 2 over x to the 2n. And then on the third fraction, I'll get 2 to the 2n over this guy, which is 2. Distribute that 2n plus 2. And then my factorials, n factorial squared over n plus 1 factorial with the square like that. Okay, so I've gotten my pieces of the fractions that kind of match each other together. What about the -1? What's that going to end up being? Well, because of absolute value, it'll be 1. Before I do the absolute value, it's still -1. What about the x's? X to the x squared. Because you got 2n plus 2 minus 2n. How about the 2's? 1 over 4. 1 over 2 squared. And then this part, I might write out a few of these. This looks a little like, you know what this is? This is n factorial times n factorial. Oh, that helps a lot. And the bottom is n plus 1 factorial times n plus 1 factorial. I hadn't thought of that till just a second ago. And I'm telling you that just to let you know, sometimes we got to figure these out too. So this n factorial over n plus 1 factorial, can you see that's going to simplify to 1 over n plus 1? And this one the same, 1 over n plus 1. So my ratio is going to end up being the absolute value of -1 times x squared, I'll just write this as 1/4, times 1 over n plus 1 times 1 over n plus 1. Now we got to do the limit as n approaches infinity. So the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n equals the limit as n approaches infinity. Maybe I can go ahead and do my absolute value here. I still need to keep absolute value though. But the absolute value of -1 is 1, so I can leave that off. See, I need to keep it because of x squared. x squared times 1/4 times 1 over n plus 1 times 1 over n plus 1. Now, what is this going to? 0. And this one, 0. So, this limit equals the absolute value of x squared times 1/4 times 0 times 0, and that is 0. That is less than 1. This series converges for all values of x. I don't have to worry about solving the inequality. We got it. So the series converges for all values of x. On the number line, if I did the graph, okay, it converges at 0 because it's centered at 0, but it converges everywhere. The interval is -infinity to infinity. The radius is infinity. Okay, make time's up. All right, I'll see you.